All right, so before we move on to section 4.9, which is going to be about quadratic inequalities and quadratic systems, I wanted to just go over a few linear systems just to refresh our memory before we move on to the next video. So this section will have a few videos, probably like 4 or 5 like the last section. Try and keep them shorter if possible. So linear inequalities. First, how do we know that we have a linear inequality? So we know that we are first going to have an inequality if we're dealing with the symbols greater than or equal to, less than or equal to, greater than or less than. All right, we know that it is an inequality based off of those symbols. An equation we know has an equal sign. All right, and then we know that it will be a linear inequality because we will have a linear equation but with an inequality symbol. So we can have the first example that we're going to do is y is greater than or equal to x plus 3. All right, so we know that this is a linear function because we have x is to the first power, so we know it's linear. And then we know it's an inequality because of the inequality symbol. All right, the difference between an equation and an inequality is in an inequality, you're solving for a range of solutions, right? You're solving for a range of solutions, and an equation will give you a specific solution, right? So when you're solving for linear inequalities, we will graph these, right? And then there's 3 steps that I want you guys to do when we're graphing. First thing is we need to graph our boundary line. So we need to graph our boundary line. So when we are graphing linear inequalities or quadratic inequalities in this section later on, we need to graph our boundary line. And we do that by taking whatever equation we have and just thinking about it as an equation. Y is equal to x plus 3. So we go to graph it like that. Right? The next thing that we do before we actually draw the graph, we need to look at our inequality symbol. If it is greater than or less than or equal to, so if it's equal to, then this means that it is going to be a solid line. All right? And then if it is just greater than or less than and not equal to, then it will be a dotted line. All right, so when we are doing this, a solid line means that we can include those points, x and y coordinates, as part of our solution set because it can be equal to it. When it's dotted, it means that it needs to be greater than or less than, so we won't include those points as our solution set. All right, so first step is we graph our boundary line, but before we actually go to graph it, we just plot the points. Before we go to graph it, we then need to look at our inequality and say, will we have a solid or will we have a dotted line? And then our third thing that we need to do is we will shade a region. And we will do this by picking points and testing them in our inequality. Usually the points that you will pick will be 0, 0. We're going to go over one example as to when you can't use that. But 0, 0 will be a good one. And then if you can't use 0, 0, 1, 0, 0, 1, something like this is what you'll want to use instead. But then we will graph and shade our regions. All right, so let's do our first example. All right, so then our first example is going to be y is greater than or equal to x plus 3. So we know that this is an inequality, linear inequality, because we have the inequality system and it's a linear function. So the first thing we need to do is we need to graph our boundary line. So we are going to think about it as y is equal to x plus 3 so that we can start plotting our points. So we know that this tells me our y-intercept is 3, so I can go up to y-intercept is 3, and our slope is 1. So I can go up 1 over 1 and then down 1 over 1 to plot the point here. So those are my graphs, right? Now the next, or my points, the next thing is I need to graph it. So now I need to look and see, is it going to be a solid line or is it going to be a dotted line? And we identify this through looking at our inequality. Since this is greater than or equal to, it has to be a solid line, right? So then I'm going to then draw a solid line going through those points. Right? I know that line is not very good on your line or your test. You should draw it using a ruler so you have a perfectly straight line. All right, so now when we do this, we break this region, or we break our graph into 2 separate regions. We have this region up here and we have this region down here. So when we're talking about inequalities, an entire region is going to be our answer. It's not just a certain set of numbers where x is 2 and y is 3. We're going to have an entire region as our solution set. All right, so then the next thing that we need to do is we need to figure out which region. So we need to shade our region. And what we are going to do with this, there's ways that you can do this by just looking at your inequality, but until we get a little bit better hang of it, until we feel more comfortable, I'm going to suggest that you do it always by picking a point. All right, so when we separate our region, our graph into two separate regions, we're going to pick one of the points that lie on that region. So we're going to pick point 0, 0. Right, you just do not want to pick a point that falls on a line, because then it will be equal to this equation and it won't tell us which one we have to graph or shade. So the next example we're going to do is going to be where we can't pick point 0, 0. All right, but we pick point 0, 0 and we plug it into our original inequality. So we're asking ourselves, is 0 greater than or equal to 0 plus 3? So 0, is that greater than or equal to 3? And that's no, because 0 is less than or equal to 3. So since that gave us a false solution, or did not work, this region that 0, 0 was in, we cannot shade. So then we have to shade the other region. So that means we will shade above the line. All right, like I said before, once we get a better hang of it, you can just read the inequalities to shade, but until then, I want you guys picking the point and plugging it in. All right, and if the point comes back and it holds that it's true, then that means it's part of the region, because every single point in that region will be true. If we pick the point and it's false and it gives us something that's not part of the solution, then we need to shade the other region. So since 0, 0 is not gave us an answer that was not correct, we need to shade the opposite region. All right, so that's that problem. One more, and then we're done with just linear inequalities, and we'll move on to a system. All right, so the next example that we have is y is less than negative 4x. So the same thing as before. First thing, we need to graph our boundary line. We need to graph our boundary line. And we treat this as an equation. So we will just say y is equal to negative 4x. So then in this case, our y-intercept is 0, so we can plot the point at 0. Our slope is negative 4, so we go down 1, 2, 3, 4 over 1. And then I can put the other line, point 1, 2, 3, 4, and over 1. All right, so now there are my points. Now remember, you don't graph your line just yet. We just plot the points. That's how we would graph it if we were graphing y is equal to negative 4x. The second thing then is we need to look at our inequality. Is it a solid line or is it a dotted line? All right, since this is just less than and it's not equal to, that means it is a dotted line. So now we'll go back over here to our points, and instead of drawing it as a solid line, we're going to draw it as a dotted line. Now, once again, you should be using a ruler in your test, so that way you have a more accurate or better looking line than I have there. All right, now this breaks it into two different regions. We have region 1 and we have region 2. So our third and last step is we need to shade a region. All right, so I said before that you should try and use a point 0, 0. But if it falls on our boundary line, which it does here, you should not or cannot use that point. So now we need to pick a different one. All right, you can pick any other point. I'm just going to pick negative 1, 0 here because I can clearly see that's away and not part of my line. So I'm going to test a point when x is equal to negative 1 and y is equal to 0. So I'm going to plug it into my original equation. So 0, is that less than negative 4 times negative 1? Well, negative 4 times negative 1 is 4, and 0 is less than 4. So that means that that point that we picked here, negative 1, 0, is part of our solution set. So we need to shade the region that includes that point, negative 1, 0. So I will shade this region here. So this will be our answer, this entire region. So any point that we pick in this region is going to be part of our solution. All right, so any one of these points will work for our original inequality of y is less than negative 4x. All right, so that is it for just this video. We're going to do another video before we move into the actual section, but the other video will just be one question. All right.